All right. This is POTD. Problem of the day, 21st of March. Oh, we got an easy question. They've been holding out on me. I finally got an easy one. All right. Flip a square submatrix vertically. Ah, okay. You're given an m by n integer matrix, grid, 3 integers x, y, and k. The integers x and y represent the row and column indices of the top left corner of a square submatrix. X and y is the top left corner of the square submatrix, and the integer is the side. Yeah, so k represents how big it is, and x and y tells you where it is. Fine. Your job is to flip the submatrix by reversing the order of its rows vertically. Reversing the order. So the 5, 6, 7 row goes to the bottom, 9, 10, 11 stays in the middle, 13, 14, 15 goes to the top. So I'm assuming x was 1, y was 0. Okay, yeah. So this tells you what row it's in, the submatrix is in, and this tells you the column it starts. And k equals 3 tells you the size. And yeah, this goes here. Okay. Well, diagram shows the grid before, and yeah, and then this would be similar. So like 4, 2 goes to the top, 2, 3 goes. Okay, so this shouldn't be, yeah, this should be 2. Do this. Okay, so 3, 6, 4, 3. Come on. Is it not? Hang on, sorry. There you go. Was it 3? What did I say? 3, 6, 4, 3. This is POTD. Alright, so basically, in essence, you have something like this. Big matrix, and then small matrix. Here, here, here. This particular coordinate here is at the x row and the y column. And basically, you know the value of k as well. So if this is like, so for example, let's say we have like a 2 by 2. So the size of the thing is 2. If this is, 1, 1, for example, right? Then so if this is 1, 1, then like the furthest row down, the most bottommost row down here would be 1, which is the starting row, plus, and then k minus 1, where k is 2 in this case. Because it would be like plus, like this is the first row, so add 1 less than k to get to the end. So you know that like top row is equal to, x, bottom row is equal to x, that 1, plus, and then k minus 1. So that's fine. And then from there, if you have like if this is like a top pointer, whoops, did not mean to do that. Pen. If you have a top pointer versus a bottom pointer, then you basically request that the top pointer, so like it'll be like while the top pointer is less than the bottom pointer strictly, swap the rows at t and b. And then, yeah, and then swapping will be like a particular operation. It will be like, well, I'll do an example. So we'll take the big example. So 13, 14, 15, 9, 10, 11, oh, sorry, we'll take this. 5, 6, 7, 9, 10, 11, 13, 14. I won't bother with the big matrix, but 5, 6, and 7, 9, 10, 11, 12, and 13, right? Yeah, 13, 14, 15. So originally, let me make sure my formula works. So x was equal to 1. Sorry, x is equal to 1. And I should also note that the column starts at y equals 0. So like the left column starts at 0, right? The y is equal to 0. And then doing the same kind of formula of like the rightmost column is equal to that left column plus k minus 1. So in a sense, y plus k minus 1. This is more important for the swapping part, but for now, we know that if the top row should point to row 1, then the bottom row should point to this by this formula, because k equals 3, should be 1 plus 2 gives you 3, which is what we want. 0, 1, 2, 3. So bottom row will point correctly. And then basically, we'll do a swap between these two rows. Then we'll increment t by 1 and decrement b by 1. So that in this case, they'll both point to the same place. And because we're doing strictly less than, it'll terminate as expected. So that's cool. So that should work fine. So this formula is good. And then from there, I'll define a function swap, which takes in 2 rows. We'll take in the grid, and then we'll take in, the top row, the bottom row, guess left col, and the right col. And the way we'll do this swap is we'll basically say, look, for, I guess, the column in the range left to right plus 1 for Python, right? So for each column, here, here, and here, we'll do like grid at this row and this column. So like grid at this row, this column, and grid at the bottom row, but same column, should be swapped. So swap them around, basically. I'll write it out properly in the code. But yeah, that should be fine, I think. I don't think that anything bad will happen if I do it like that. So yeah, if I say, let me just try this. I don't see anything bad happening. We'll see. So top row is equal to x. It's not really necessary to do that, but bottom row is equal to, we said x plus k minus 1. And then left will always be y, right? Which column we're always starting in. And then right will always be y plus k minus 1. Then from there, while top row is less than bottom row, we know that we're going to have to eventually increment this guy and decrement this dude. Fantastic. And then just swap the rows. Not def. Self.swap the rows pointed by, so I'll give the grid, and then pointed by the top row and the bottom row, given that we only care about the columns from this left to this right. Yeah, and then, so I'll just make that function def swap self grid t top, bottom, left, and right. We'll say left col here just to make it obvious. All right, and I'll do the same. Row. Whoa, that was crazy spelling. Col. Okay, so what did I say? So for the columns in range left col to right col plus 1, because we're keeping things exclusive at the end. So we don't actually have to do the temp thing because Python, I think, supports the in-place like swapping thing. Like top row current col, grid bottom row same column should equal each other. So if you type it like that, Python knows what I want. And then yeah, I don't have to return anything, do I? Oh, I do. I return the same. I return the grid, I guess. That's interesting. I wouldn't have thought I'd have to return anything, but fine. I guess you could do, I guess there's no restraint saying you have to do it in place, but I feel like it's easier to do it in place. Now, do I have any crazy mistakes? So let me just think about the swapping thing first. So for each, so given that you have 2 rows, we're going to go from the column marked by y up to y plus k minus 1, right? Y and then plus 2 will give me that column, yeah. So for each column in these 2 rows, top row at that column versus bottom row at that column should swap. Yeah, that's fine. That makes sense. So these two swap, these two swap, these two swap. And then, yeah, that should be fine. Left, right, and then obviously some of these variables aren't really necessary. Like I could just say x and x plus k minus, like these two are necessary, but I could just keep these y and y plus k minus 1, but I'd rather have them explicitly named. Yeah, I don't know. I mean, it is an easy problem. I don't think it's meant to be super tricky or anything, but I'm worried that I've missed something. Well, I was hoping I'd get a. Do I want to? Are there any other tests? Wait, is how? I'm assuming the thing can be one. Okay, so let me try some small cases. So like, let's say I have a grid of size 1, right? So like, straight up just a 1, and then I guess x has to, like, x and y have to be at least 0, and k has to be at least 1. Okay. Let's just make sure the small case works. Okay, fine. Very good. It's able to handle that. Well done. What if I have like 2 things? That should also still be fine. Fantastic. What if I have a 2 by 2, and then maybe I'll have an extra column. Wait, yeah, I'll have an extra row. 3, 4, 5, 6, and I want to swap. So row 1, column 1. So it's focusing on the. Wait, no. Row 1, column 0, sorry, and size 2. So I'm trying to swap these two guys around. All right. Yeah. Oh wait, what? Oh yeah. 3, 4, and 5, 6 swap. Yeah, I don't know if it hasn't failed. Like I feel like the logic makes sense. Fantastic. Okay. Yep, that was fair enough. I don't think there was anything crazy there. There's not really much else you could do. Oh wow. Okay. I mean, I feel like the overhead of importing the whole NumPy library is a bit crazy, but fine. I mean, this is true. I mean, NumPy is good at this stuff. But that's funny. X to x plus k, y to y plus k. So that's basically getting the entire submatrix is equal to x plus k, y to y plus k flipped. Yeah, fair. That's funny. I didn't realize you'd. I guess because it's a NumPy array, right? When you do this, and then you have to return it back into a inbuilt list. So that's fair enough. Anything less insane, or there you go. This is more normal. So you get the size, and then for I in range k over 2. Interesting. For j in range k, so I guess it's like telling you the number of rows you need, because like there's this many pairs of rows that you're gonna have to swap, and then j for all the columns. Interesting. Grid at x plus I, y plus j. Yep. Grid at x plus k minus 1 minus. Yes, this is doing a similar thing. It's going for like, this is like your top row, this is like your bottom row, and then this is like the same column twice, is equal to, and then you swap them around. I'm surprised this one ran for. I feel like I did a similar thing, right? Conceptually, it's the same. Like I got a while loop and a for loop. Like double loop basically. Same thing. I don't know. It's interesting. Anything else interesting? Yeah. So this was probably the only thing that was a bad idea. You didn't have to. You could do it in place. There was no need to copy it. But fair enough. It works. Unless the question did say not to change it, but I mean they should make that more clear anyway. Yeah, no, it's. Yeah. All right, well that was easy. Good stuff. What does the hint say? Yeah, there you go. I don't know why I'm curious. I just Mid-level, yeah, sure, mate. If that's mid-level, then